Homework 1.4, section complex numbers. Video 5, homework due May 16th, 2020. In the previous video, we discussed the addition and subtraction of complex numbers. Just a reminder, complex numbers are numbers of the form a plus bi, where the a and the b are any real numbers that you want them to be, and I by definition is the square root of -1. And at some point, we'll talk about this red statement more in detail. But for now, let's take a look at some of these multiplication problems. So let's start with the first one. That's always a good place to start. In a nutshell, your instinct should kick in using tools and skills that you've seen in past algebra experiences. For example, when I see a problem like this, 5i times 2 plus 3i, my instinct is to use the distributive property, where you distribute the first factor to each term in the second factor. When I see the second one, my first instinct is to FOIL it, and we'll talk about what that means in a moment. Now this third one, my instinct and your instinct may say different things, so we'll cross that bridge when we get there. But let's just jump into it and see what happens. On the first one, we're asked to multiply 5i times the quantity 2 plus 3i. This reeks of the distributive property, which says if you're multiplying something in front of parentheses, multiply to each term inside the parentheses. Remember, terms are separated by pluses and minuses. This has two terms. Well, if the I were any other letter, I don't think we would be worried too much about this. 5i times 2 is 10i. But what about 5i times 3i? Well, 5 times 3 is 15, but what about I times I? Well, by definition, when you multiply something by itself, you're squaring it. So in the second half of the distribution, 5 times I is 15. 5 times 3 is 15, but I times I is I squared, which is what you would do if it were any other letter. Now, is that our answer? Well, I don't know. Does our answer have this form? Something plus something with an I. Not quite. Here's the something with an I. But here's something with an I squared. Oh, great. Is this going to take us to another set of numbers? We have an answer that doesn't belong to this set, so we need a bigger set of numbers? No. We just got to figure out what to do with the I squared. So what can we do with the I squared? Well, what do we know about the number I? Well, we know where it came from. It's right here. We know that I, by definition, is the square root of -1. Again, if you ask me what is I will tell you the square root of -1. And if you ask me what's the square root of -1, I will say I. And if you ask me why, I'll say because. That's its definition. Quit trying to solve for I. It's not something to solve for. But I would like to know what I squared equals. Now, there's an important problem-solving skill that I'm about to share with you. And throughout this whole class, I will try to share as many problem-solving skills as I can that can help you solve problems in general, not just math problems. Sorry, this computer fell asleep. It's charging my phone. So what's that problem-solving skill that I'm about to introduce to you? It's actually pretty intuitive. How do you take what you know to figure out what you don't know? Or more generically, how can you connect what you have with what you want? How do you get from where you are now to where you want to be? And the answer is, well, it's not always that easy to answer. If I knew the answer to that, I could solve everybody's problems. But let's jump on that. This is what I know about I, but what I would like to know is what I squared equals. So what can I do to this to learn something about I squared? Well, don't we have a tool in our arsenal that says whatever you do on one side of an equation, you can do on the other? Well, I currently have I on the left side of this equation. I would like for it to say I squared. So why don't we square both sides? Well, squares and square roots are inverses. More on that later. And basically they cancel. So while the I squared just sits there on the right side, the square and the square root cancel, and that leaves me with a -1. And now we got an equation that says I squared equals -1. That's weird. I thought when you square a number, it comes out positive. When you square a real number, it comes out positive. Remember, this guy wasn't real. He didn't live on the number line. I even showed you where he lived. but he doesn't follow the real number rules. So yeah, when you square the number I, you get -1. So we're going to take advantage of that over there. But before we do, I want to write one more red sentence over here. In a previous video, I mentioned that there's really only 2 new things you need to learn. One of them is this red sentence up here, and here's the other one. If you see I squared, I see 1, change it to -1. If you can remember these 2 sentences, those coupled with the algebra skills and theory you already have will make this section pretty straightforward. There are a couple of rough spots. We'll talk about them in the next video. But hey, I see an I squared, and according to that sentence, when I see it, I should change it to -1, so I'm going to. So instead of 10i plus 15i squared, this becomes 10i plus 15 times -1. Oh, I know 15 times -1. It's -15. This looks a little bit better. Remember, we're trying to get a complex number answer. Something without an I plus something with an I. We're practically there. This answer is actually correct. If you typed it in the homework, it would say it's right. However, to be persnickety, when you write a complex number, it's pretty standard. In fact, it's called standard form, to write the real part first and the imaginary part second. So the real part here is -15, so I'm going to write it first. And the imaginary part is 10i. But because I'm writing it second and it's positive, I'm going to put a plus in front of it. So we can say confidently that the answer to the multiplication problem is -15 plus 10i. Really, it's just business as usual, with the addendum that when you see an I squared, you change it to -1. So let's try the second one. Multiply the complex number 2 plus 4i times the complex number 3 minus 2i. This is where you would FOIL. For those who don't remember, FOIL is a gimmick for multiplying 2 binomials. A binomial is an expression with 2 terms, so 2 terms being multiplied. You may remember what the F, O, I, and L stand for. F stands for the product of the first terms. O stands for the product of the outer terms. I stands for the product of the inner terms. L stands for the product of the last terms. If you think you've got it, I invite you to pause the video and see if you can get to the answer, all the way until the standard form, something without an I plus something with an I. But I'm going to go ahead and FOIL this out. First part of FOIL basically says multiply the first term in each factor. So 2 times 3 is 6. The O in FOIL stands for multiplying the outer terms. So 2 times -2i, which is -4i. If you'll notice, all I really did is distribute the 2. The I part of FOIL is a gimmick for multiplying the inner terms. So positive 4i times 3 is positive 12i. And the L part of FOIL is a reminder to multiply the last terms in each parentheses. This is where you should be careful. Positive 4i times -2i. Positive times negative is negative. 4 times 2 is 8. I times I is I squared. And again, notice all I did was distribute the 4i to the second factor. So really, FOIL is just a gimmick for doing the distributive property twice, which is why some people just call it the double distributive property. Hey, we got a mess of terms, and we should really clean it up because we don't quite have standard form yet. 2 things. Number 1, we've got like terms. And number 2, and we're pressing, we've got an I squared. And if you see an I squared, you change it to -1. So let's clean this up real fast. This becomes -8 times -1 because I see an I squared. But -8 times -1 is positive 8. If you do enough multiplication, you start instantly realizing that an I squared simply changes the sign of the number in front of it. Because an I squared becomes -1, and multiplying by -1 just changes the number sign. So, now that we've cleaned up the I squared part, let's track down our like terms. Our real parts are 6 and plus 8, so that's 14. And our imaginary parts are -4i and positive 12i. Well, when you combine a positive and a negative, you subtract, so 12 minus 4 is 8. Because the larger number was positive, so is their result. And we were combining like terms, so it's an 8i. And so just like that, we get 14 plus 8i. Again, fairly straightforward, as long as you rely on your previous algebra skills, along with the new fact that if you see I squared, you change it to -1. For this last one, I'm just going to warn you about the setup, challenge you to find the answer, and then tell you what the answer is and see if you can fill in the details. But the last multiplication problem, a lot of people make a mistake on. Square the quantity 4 minus 7i. The reason a lot of people make a mistake on this is because they want to bring out a distributive property that doesn't exist. Let me square everything. There is no distributive property that says you can distribute a power across a subtraction. You can distribute multiplication across subtraction. You can distribute multiplication across addition. But there is no power rule. There's no distributive property rule that says if you have a binomial, we'll call it a plus b, just to represent a generic binomial, not necessarily a complex number. And when you raise it to a power, there is no rule that says you can distribute the power to each half. In fact, you need to break yourself of this habit real fast. There are distributive properties, but this is not one of them. So how do you do this if you don't distribute the square? Well, what does it mean to square something? It means to multiply it times itself. So the way you square a binomial, and in this case square a complex number, is you multiply it times itself. And now you just do the same thing we did in the previous example. So I'm going to skip the details. If you want to go ahead and pause the video and try to get the answer, you can. Or I can just tell you the answer now and see if you can figure it out in a moment. If you give me a second, I can tell you what the answer is. It's going to be -33 minus 56i. Let me double check that. 49, 39, 33 negative. Yeah. So I challenge you to actually FOIL this out and see if you get -33 minus 56i. I'm 99% confident that's the correct answer. In the event that I'm wrong, I'm sure I'll hear from one of you. And if I am wrong, then I'll make a retraction video. All right, so now that we've talked about multiplication, I would recommend going into the homework and trying the following problems. In homework 1.4, I would try questions 10, 11, 12, 13, and 14, which are almost the end problems. There is one other 15, but, well, you'll take a look at it and you'll be able to handle it. I have confidence in you. In the next section, in the next video, we'll talk about actually square rooting negative numbers, and we'll finally get to use this first sentence up here about if you see the square root of -1, we'll change it to I.